Okay, let's see. The mistake pointed out to me yesterday was actually here. Okay, I'm going to check here. Okay. Okay, let's see again. What did I do? Right. The A is correct right now. The A is correct. So in putting T as 6, right? I'm simplifying my K. If I put my T as 6, 1350. Yep. I think this is wrong. This is wrong. It ought to be like what the two of them pointed out to me. It was supposedly like that. Am I right? It's correct now. Thank you for telling me my mistake. No, it's so embarrassing that I made calculation error like this. Right. Okay. So that cascades, And once again, the good thing is I can make the correction quite readily. Right. Katish, you failed your mission. You're supposed to check. You're supposed to. Your job, Katish, to spot my mistake also, to check my mistakes, to catch me when I'm wrong. That's your job, Yep. Okay, sorry about the mistake, Yep. Okay. In fact, I'm quite pleased that my mistakes have been spotted and pointed out, so that it means I know that people are actually looking into it, Yep. Thank you for this, Okay, let's go back to our tutorial. Okay, wait, let me slow down a bit. Okay, in case you need to see this mistake again. Yep. Okay. Okay, if you have no questions, let's look at number 10. The number 10 shows you a slope field, and now you're supposed to match it to the so-called solution A, B, C, D, or E. For the case of A, right? For the case of A, you know that if you draw a typical graph for A, it look like this. This A. For the case of B, it will look like this. So the way to look at it is, do you think that the slope field is anything close to A or B? You think so? No, right? It's not. Okay. Is there something that's going on? I hear some digital, some radio, some media. For me, what? Mahil, where is it from? Where's that media being played? Somewhere in the class. Okay. So you look at A, B, and C, right? You find that the slope field given doesn't match A, B, or C. Because if you sketch a graph of A, B, or C, it doesn't look anything like the slope field. Now, for the case of part D, right? Cosine graph, we all know how cosine graph looks like. It looks like this. And you find that A, B, C, and D, right? They are nothing close to what you see in the slope field. But in the case of elephant, yep, I think that this one matches elephant. In the past, MCQ for AP used to have 5 choices. But some years ago, they changed it. MCQ only has 4 choices. So it's a good thing, I know. That means your chance of getting it right by random guessing, right, is 1/4 compared to last time 1/5. So higher chance of getting correct. And based on past experience, right, students normally fare badly at MCQ, because there's no mercy, is it? It's either get right or get wrong. So on 45 MCQ, if you get 10 wrongs, you are just around the average. A good MCQ score should be around 38 upon 45. If you get 10 wrong, you're below 38. Right? Of course, a above 40 is the best. 40 and above, you are in good shape. Right, so number 10 is quite straightforward. Therefore is E. Any objections? Okay. Sometimes I use a word like this because it started from in the courtroom, Courtroom, when I go to court cases, right? Sometimes the prosecution will jump from the seat and raise it up, Objections to what, Objections to the way the defense counsel tried to quiz me. I was put at the stand, and then the defense counsel will start to bombard me with 1,001 questions, Yeah, I've gone through this sort of thing before, and it must be very firm, must be very steady. You don't, then your evidence is not credible, because as a police investigator, you have to actually be very steady, And then if your prosecutor is very alert, he will jump from the seat and object to the question raised. Sometimes, yeah. Okay. Anyway, let's go to 11. A show of hands, who have already tried question 11? Oh, good. This class is good. Okay, a good number. Okay. For the case of 11A, right? Let's see which one it matches. For 11A, a quick one would be when x is 0, you will have infinite gradient. So that's the best. You look around, to look for those with infinite gradient at x equals to 0. A good check. I think that this one, I think this one. Okay. This one is a possible choice where the gradient is infinite at x equals 0. Let's check if there are others. Don't jump to the conclusion, because there could be more than one. So I think that based on this first cut right now, I therefore think that part A should be IV. Am I right? For those who have done it, you agree also IV. For the next one, for part B, when y is 0, where will y be 0? Along the x-axis. When y is 0, the gradient is infinite. So let's look around the graph and see which one has infinite gradient along the x-axis. This is one possible choice, VI. Are there any other choices? Don't have, I think. Don't have. So the part 1 and part 2, A and B is quite easy. This is going to be VI. So you start out with something that's obvious, is it? Obvious, right? Because it's very easy to check for these two. And luckily, there are no contenders for infinite gradient along the x-axis, so that makes our life easy. Then maybe I will do D first. If I were given a choice, I'll do D first, because D is very easy. For the case of part D, right? For the case part D, I realized that when y is 1 or -1, the gradient is 0. So look for those the slope field where the gradient is 0 at y equals to 1 or -1. I think it looks like this one, like this. Right. Okay. Then for maybe I look at E first. E should be easy. I look for the easy one first. Okay. Let's look easy one first. For the case of E, right? At x as y equals to -x, you have 0 gradient. At y equals to x, you have infinite gradient. Let me see. Am I right now? Wait. I don't think I'm right. I'm doing right. Okay, wait. If y is equals to x, let me see. If y equals to x, right? Y x, right? Let me see first. You're going to have 2x over 0. So it's infinite gradient. It's true. So along this line, y over x is true. When y is minus x, it's not what I think, When y is minus x, right? You get 2x below, you get 0 on top. 0. Okay, it's true. Okay. So look for these two characteristics now. Infinite gradient along y equal to x, and 0 gradient along y equal to minus x. So let's see again. infinite gradient along y equal x. Let's see. Which one has infinite gradient along the line y equal x and zero gradient along a? I think that this one looks sus. I think let's see whether it works. Okay, let's see again along the line y equal x. Looks like it. And then along the line y equal to minus x. I think so. So I think based on this, right? Based on this, I think that this one ought to be graph 1. Okay. Then the next one is, let's look at part C. Part C, right? Part C. Based on this, right? Based on this, I will know that the gradient is always positive, you know. The way part C, the gradient for part C, right? The dy is also exponential. It means the gradient is always positive. So between the last two graphs left, we want to see which one always have positive gradient. So anyone that has negative gradient is out, you know. Positive gradient. Okay, this one got some negative gradient, right? So it can't be this one, you see. So therefore, based on my judgment, I think that this one, right? V ought to be C. Yeah, because the gradient ought to be positive. Okay, nevertheless, let's still look at this other one. This one again, let's do this one. Even though we think that it has to be this, let's judge why again. For this one, for when you involve a periodic function, right, it means things will repeat, which means when x is 0, when x is pi, when x is 2 pi, and so on and so forth, you have 0 gradient. So let's see again, let's see this one. So again, can you see 0 gradient along here, 0 gradient along here, and 0 gradient along here, right now. And same thing for the y, no? When y is 0 gradient, when y is pi, when y is 2 pi. Okay, this is almost 0. Not exactly, okay, this one I think we remove that again. Maybe one more step, it will be 0 already. Right, so these are places where you see that it's periodic, you know, it has 0 gradient. So therefore, I'm quite sure that this therefore has to be part 3. So if a given 6 graph, you always do the easy ones first. So eliminate the possibility of getting, or eliminate the possibility first for the last few. Okay. And for this one, right? This is where you gotta exercise your gut feel. Sketch a graph of the solutions that satisfy the given initial condition. Okay, y0 equals to 0. So it's here, y0 equals 0 means it must pass through this point, okay? So based on this look view, okay, based on this look view, right? I think it's going to look something like this. More like this type. Y0 equals 0. Anybody has something different? Like based on what I see, I exercise my gut feel. And then y0 is 1, y01 is here. So based on this, right, I see that it's actually a horizontal line. The thing is, if your gut feel differs from others, then it's kind of like too bad, I mean, yeah. Then y0 equals to 2. This is 2, right? This is 2. So I think it should be something like this. So I think my graph will look like this. Let me know if you have something different, you know. Okay. Okay, for question 13. Okay, you're supposed to draw the slope field for this simple graph. When y is 0, the gradient is 0. When y is 0, is here. You got to take a ruler to do it, you know. You cannot do it like me, you know, like freehand. Not allowed. When x is 1, it's also 0 gradient. Okay. when x is 1, it's also 0 gradient. Right. So now for the remaining 6 points, we will do them slowly. When x is minus 1, this gradient is 2. So for a gradient of 2, right, you have to draw a gradient of 2 by actually creating a point here and aiming like this. No? And this is a gradient of 2. You have to do it, you know. Let me do this guide again in green. You really have to do it because yours sincerely will take a ruler. I might not have a ruler in hand, but I will always take something straight to actually see that it is truly gradient 2. You cannot try to just anyhow guesstimate, it won't work. It's not going to work. When x is minus 1, then the gradient now is 4, right? When y is 2, right? When y is 2, and x is minus 1, the gradient is 4. So for gradient 4, right, I will artificially create more points like that and like that. Then the gradient of 4 has been done. So I'm going to draw gradient of 4. Hey, wrong. I did on the wrong point. What's wrong with me? Okay, so gradient of 4, right? So I got to create fake points. 2, 8. Okay, 2, 3, 4. And then my grid points tells me that gradient of 4 is like that. So I draw my gradient of 4. You know what I'm saying? It's only using points like this to guide you, then you can actually do it more accurately. You know? Then now the next point is 0, 1, the gradient is 1. So gradient 1 is not bad because quite easy because the guide points are already there. Then gradient of 2, right. Okay, then draw it more properly. You gotta draw it nicely, you know, with ruler, no? Then when x is 2, y is 1. So I think it's a minus 1 gradient. When x is 2 and y is 2, the gradient is minus 2. Okay, I'm done. Right, so you must draw it very carefully, you know. It's good to take ruler to, you see the grid, the green color grid, right? The grid points I've done it freehand. No? I expect you to do it using ruler, pencil, and do some measurement, you know, so that it can be as accurate as you can. You know? Okay, 13B. Okay, someone is high spirit. Did I tell before? There's actually a wordy problem that if you can solve it, I think you can get a good reward. And that's to solve the congestion in the checkpoint, at the checkpoints. Solve the traffic congestion at the checkpoints. It always happens, and poor people have to wait there for 8 or 9 hours. No, I was told. I never had that long a jam, but I do experience 2 hours jam there before. If you can solve this traffic jam problem, I think LTA will take your idea, maybe give a big reward. Like, since you're high spirit, tell you this thing, maybe you can think of a solution. You know. Who is that? Who is in high spirit? I hear some humming just now. Ooh. Okay, maybe I'm hearing things. Okay, for 13B, to solve this DE, obviously we have to do this Oops, there's a mosquito. Shucks. One day if I see God, I'll ask him why he created mosquitoes. Like mosquitoes. I don't know why, it was flying just around here. Quite a big one, I'm just scared that I get dengue. Yeah, if you can find a cure for dengue, you also become sought after, no? Yeah. So far, I was told there's no cure for dengue, They just lie you in bed and then give you glucose drip, and hopefully you recover by yourself. Human body is phenomenal, no? We recover by ourselves, You can't be a robot that recover by itself and get injured, There's something phenomenal about human body. Self-heal, not yet. If you can make a robot that's like this, right? Wow. You know the one at USS, the what do you call that? Transformer. The Transformer. My daughter likes it a lot. The robot in the screen looks phenomenal. Okay. So if you solve 2B, 13B, right? This is what you get. I can check my calculations. And then using the condition that when x is 0, y is 2, that's actually equal sign, not minus. The thing is, oh shucks, I'm going starting to scratch already. The mosquitoes. Nowadays the Mopigo doesn't work, Mopigo, when you get skill right, the mosquito doesn't really work. I used to scratch it. So you can find a way to kill all the mosquitoes at one go. The bio and chemistry students, can you find a way to? Who eat mosquito? The lizards, what? Only lizards, right now. Yeah, but you don't need mosquito. You can eat other insects. But how does a mosquito play? What role does mosquito play in the food web? If without mosquito, there's other food for the frog, for the whatever. Mosquito pollinate flowers. But we can have other agents to do it, but because supposedly if I take mosquito out of the ecosystem, will it collapse?
Okay, but like if you have mosquitoes pollinating this one plant, other insects and other stuff can't. There's also like areas where.
Oh, so that means there are things that mosquito can do that other insects can't, is it? Find that out, and bridge the gap. Then mosquito will go extinct. Bio student Arohi, you got a mission. Your next ISF medal is waiting. Find a solution for mosquitoes breeding, kill it,
No, I think what I say is that mosquitoes are food for relatively bigger than small animals. Which means that the small animals can have food so that they become food for bigger animals.
No, but if we remove mosquitoes from the ecosystem, can we find substitutes?
Food substitute from mosquitoes.
I mean, okay.
Like in some areas, mosquitoes are like the only source of.
Those places let them thrive, it's okay lah. But in urban area like Singapore, can we have a way to eradicate mosquito entirely? Okay, just ignore me.
A lot of plants, but as you can see, a lot of plants produce a lot of their pollinating agents.
I don't think they're native.
Okay, for this question, right? Because this is a particular solution, let's write down the domain for this particular solutions. Okay, are there values that is not allowed? I think in this case, x can be anything. X can be anything. Yep. Okay, I don't see any reason why anything cannot be in the domain. So if you draw a sketch of this graph, I believe that this sketch of this graph will look something like this, you know. Will look something like this. Okay, if you were to draw this graph, it should look something like this, the solution curve. It doesn't ask for it, but if you do draw, I believe that it look like this. Okay, then it says find interval where fx is increasing. So you can see that it's increasing on this interval. Okay, let's see who can read my mind to tell me that question mark. Chen Yin, you have an opinion? What should the question mark be?
1.
Brilliant! How do you get 1? Because at this point here, where it experiences a local max, the dy dx is 0 right now. So which means based on the dE, y minus xy is equals to 0. This implies that x is equals to 1. Because at that point, y isn't 0, is it? So therefore, x has to be 1.
Shouldn't it be open bracket?
Increasing, right? Up to this point, it is still deemed to be increasing. Like that. Because starting from left to right, it keeps going up until it hit the max when x is 1. So it's deemed to be still increasing. Yeah. By the definition of increasing with a closed interval. So I'm looking back to check. Let's check again to see if I am right to use closed brackets. Tyler is helping us to look back into the notes to see if shucks, it bit this mosquito is very, very unfriendly.
Mosquitoes is fun. The moment you kill them, when you see all the blood flow, that's fun.
May not be your blood, you know. It may be your friend's blood, you know. It could be your neighbor's blood, you
Still be
know.
fun. Still be fun.
Fun? Why should it
You
be?
just see the blood.
Okay. I beg to differ.
My last year morning activity, wake up, go into the toilet, kill all the mosquitoes on the wall.
Speaking of mosquitoes, where is it? In your body? Where do you complain? You complain is a case.
It's the, I don't think it's out. I think it's the one that white. It's not, I don't think it's the blood, it's the pink one.
Okay.
But it's fun.
Really? So how your agreement is a closed interval on the side. Right, so that completes the tutorial 4.1. Shall we now embark onto tutorial 4.2? I haven't finished it.
I haven't.
Okay, show of hands who haven't finished 4.1 on their own, you know. Tutorial 4.1, Kenneth looks like it's only one hand, you know. Interesting. Yep.
The answer says 1 is.
Okay, it ought to be closed. Why should it be open? Let me see. Yeah, it put open bracket, but